For decades, self-driving cars were just sci-fi, right? Stuff you'd see in the movies. But now, with companies like Waymo running actual robotaxi services and Tesla's autopilot becoming a common sight on the highway, they are very, very real. So today, we're going to break down how this incredible technology actually works. Okay, let's get into it. It really all boils down to this one question. How on earth does a machine see the world around it, think about what to do, and then react, often way faster and more accurately than a person ever could? It's a huge technical puzzle, and the solution is this amazing mix of some seriously cool hardware and incredibly intelligent software. So, to make this whole thing super easy to understand, we can break down the entire process into a simple 3-step loop, and we're going to follow this loop for the whole explainer. First, the car has to sense its environment. Then, it has to think about what all that information actually means. And finally, it has to act on that decision. Sense, think, act. Simple, right? Let's kick things off with the senses. To drive down the road, a car obviously needs to be aware of what's happening around it. But instead of human eyes and ears, it uses this whole array of electronic sensors that, when you combine them, give it a picture of the world that's, in a lot of ways, way more detailed and reliable than what we can perceive. And this right here really shows you the technological jump. I mean, where we're relying on our sight and sound, the car has this whole team of high-tech gadgets. So let's break down the big three you always hear about: cameras, radar, and lidar. Each one has a totally unique and totally crucial job to do. Okay, first up, cameras. These are the easiest ones to get, right? They're basically the car's eyes. They are fantastic at recognizing things that need a bit of interpretation, like reading a speed limit sign or telling if a traffic light is red or green. But, and this is a big but, just like our own eyes, they kind of stink in the dark, in a downpour, or if the sun's glaring right at them. And that's exactly where radar comes in. Think of it as radio vision. Radio just sends out a bunch of radio waves and then listens for the echoes that bounce back. This makes it insanely good at two things: figuring out how far away something is and exactly how fast it's moving. And here's its superpower. It sees right through fog, rain, and snow. It's the all-weather MVP of the sensor team, for sure. And then you've got lidar. It's a funny word. It just stands for light detection and ranging. Now, this is the tech that creates a super high-res 3D map of the world. It works by shooting out millions of laser beams every second and measuring how they bounce back. This creates something called a point cloud, which is just a fancy way of saying an incredibly detailed 3D model of everything around the car. It can define the exact shape of a pedestrian or a cyclist even in pitch black darkness. But the real magic isn't in any single one of these sensors. The secret sauce is how they all work together. It's a process called sensor fusion. The car's AI brain takes the color video from the cameras, the speed and distance from the radar, and that super detailed 3D map from the lidar, and it fuses them all together into one single coherent picture of reality. This teamwork is so important because it provides redundancy. If a camera gets blinded by the sun, the radar and lidar have its back, making the whole system incredibly robust. Okay, so the car has sensed the world. It's got this fire hose of data coming in. So now for part 2 of our loop, the think part. How does the car's AI brain actually process all of this and make sense of it all? Well, the AI's thinking can pretty much be broken down into 3 questions that, honestly, any human driver is asking subconsciously all the time. First, perception. What am I even looking at? Second, prediction. Okay, what's that thing probably going to do in the next few seconds? And third, planning. Based on all that, what's the safest and smartest move for me to make right now? So that perception stage, that's where all the deep learning and AI training really pays off. All that fused sensor data gets fed into these specialized AI models. You can think of them as digital pattern recognition engines that have been trained on literally billions of miles of real-world driving. And all that experience lets the system instantly classify everything it sees, saying that's a car, that's a stop sign, with just mind-boggling accuracy. Now we get to what is arguably the hardest part of this whole equation: prediction. The AI doesn't just need to see what's there now. It has to guess what's going to happen next. Is that car about to merge? Is that person staring at their phone going to step into the street? This is a massive challenge because, let's be honest, it's trying to predict the behavior of humans, and we can be pretty unpredictable. So once the car has a pretty good idea of what everyone else is about to do, it moves on to planning. This is the last step in the thinking phase. The computer calculates the exact path, the trajectory it should take for the next few seconds. It's a path that has to be as safe, as smooth, and as efficient as possible, all while, obeying all the traffic laws. So the car has sensed, it's thought, now it has to act. But how it's allowed to act and how much of the driving responsibility it can actually take on, well, that's a really big deal. The whole industry grades this using a standard scale, from level 0 to 5. It was created by the Society of Automotive Engineers, and you can really just think of it as the car's official driver's test. So this scale goes all the way from level 0, which is just your basic car, no automation at all, up to level 5, which is kind of the holy grail. But the key differences are really in the middle. Levels 1 and 2 are all about driver assistance. Think adaptive cruise control or lane keeping. The car is helping out, but you are 100% the driver. Level 3 is conditional automation, where the car can drive itself in some situations, but you have to be ready to grab the wheel at any time. The real game changers, though, are levels 4 and 5, where the car is truly, actually driving itself. Level 4 is what you're seeing today with services like the Waymo robo-taxis. The car handles absolutely everything about the drive. No human needs to be involved. But, and this is the big catch, it can only operate inside a limited, pre-mapped area. We call that a geofence. So it's fully autonomous, but only when it's on its home turf. Now, that's the cutting edge. Let's step back a bit to level 2, because this is what most people with a newer car might actually get to experience. Systems like Tesla's autopilot fit in here. The car can handle both steering and your speed, but it is absolutely critical to understand that this is not self-driving. The human is legally the driver and has to stay completely focused, hands on the wheel, eyes on the road, all the time. So, if we've got all this incredible tech, what's stopping us from having a level 5 cars zipping around everywhere? Well, it turns out there are still some pretty big hurdles for the industry to clear. Probably the biggest challenges are what engineers call edge cases. These are the rare, totally bizarre events you just can't plan for, like a flock of birds suddenly covering the road or a construction worker waving a flag in some weird way. Then there's still bad weather, which can mess with the sensors, and on top of all that, you have these huge questions about proving safety, legal regulations, and, of course, the ever-present threat of cybersecurity. But even with all these hurdles, it is so important to remember the why. Why are we even doing this? Because the potential payoff is absolutely massive. According to the data, a staggering 94% of all serious car crashes are caused by human error. The ultimate promise of this technology is to engineer that one single biggest point of failure right out of the system, and in doing so, to save millions of lives. The technology is moving forward at an incredible speed. These cars are learning from every single mile they drive. So the final question really isn't just about the tech itself. The car is learning to navigate our world. The bigger question is, are we, as a society, ready to navigate a world where we share the road with them?